everyone, my name is Gozo Wang, and I work as a field application engineer in Moldex3D. Today, we would like to introduce several past processing tools in Moldex3D. First of all, we would like to introduce how to measure the linear shrinkage by using our tool. And then we will also talk about how to deal with the shrinkage compensation design by using Moldex3D. So now let's see the model we have here. We can see the geometry of this model is a connector. I think the dimension of a connector is very important because a connector needs to work with the other parts. For example, there may be lots of plug-in and remove in their usage. So that's the reason we choose this model to show you how to get a precise dimension. So because we have already finished the analysis, we have gone through the filling, packing, and the warpage simulation. Now let's shift to the warpage result directly. The result we are showing here is the total displacement. So what is the total displacement? The process we are dealing with here is the injection molding process. So we need to pump the melt plastic material into the cavity, and then we need to cool down the temperature of our material inside the cavity. But in this kind of procedure, the shrinkage also happens. And the shrinkage is not always even. It depends on the thickness or the difference of the temperature distribution. So that's why the uneven shrinkage happen, and we call them warpage. So how to deal with how to measure the warpage situation? In Moldex3D, we offer our user to measure the deform dimension by using our post-processing tool. We can see the tool, this one, is called measure distance. So let me just open this one to show you how to use that. So for using this tool, we need to select 2 points. So let me just choose the first point here and the second point here and click yes. So now we get a tag here. In this tag, it includes the original dimension of this length. We can see the original length here is 17.2 millimeter, and the deformed dimension here is 17.124 millimeter. So we can see by comparing these two values, we understand there is the shrinkage, right? And our tool can also help us to calculate the linear shrinkage. Here is the linear shrinkage. So we can see the linear shrinkage in this model is about 0.5%. So by checking this value, we may have another question, how to deal with the shrinkage. Because the shrinkage always happens, but how to deal with that? I think there are roughly 2 ways to deal with the shrinkage. The first way is we could try to optimize the processing conditions. For example, we could try to optimize the packing conditions. So we can try to pump more material into the cavity and try to balance the shrinkage. And the other way is we can just do the shrinkage compensation design. So what is the compensation design? The idea of the compensation is because we know the shrinkage always happens, we could just try to scale the size of the cavity a little bit larger. So by dealing with this way, even the shrinkage happens, the size of our product will just exactly miss our design value. So it's the idea of the compensation design. And in Moldex3D, we offer our users several tools to deal with the compensation design. So let me just open this one. This one is called deformation. So in the deformation, we can see one of the features in the deformation here is called compensation. And we offer 2 methods to do the compensation. One is isotropic, and the other is anisotropic. The idea of the compensation in our tool is we offer a preview result for our user to know how will the deformed dimension will become if we consider the compensation design on our cavity. But it's just a mathematical preview. So now let me just use a value to show you how to deal with that. So now we use 1%, we consider 1% of the compensation and we can see the tag here is being updated, and the deform dimension here now is 17.295 millimeter, but it's a little bit too large, right? So now we can use the value we get earlier from our first run is, I remember that is 0.444, right? So we can use this value. So now we can see the deform dimension here is updated again, and the deform length here is 17.2 millimeter. So we could just use this value to update the size of our cavity and build another model to do an analysis again. And here we also offer another tool. This one is called Explore Deform Model. So let me open this one. So by using this tool, we can help our user to explore the deform model as a STL file or other formats. And we can also consider the scale factor and the compensation at the same time. And they can define the value all by themselves. So by using this tool, they can do the compensation design based on its experience or what they want to try. And here we will show you another way to deal with the compensation design, because we know the Moldex3D Studio is also a pre-processing tool, and so we can do the pre-processing job by using Studio. So we can just copy the first run and use our tool to scale the size of our cavity. So now let me show you the run 2. So in run 2, we also have already finished it. The idea of the run 2 is we copy it from run 1 and scale the size of our cavity. So now let me measure the distance. So we can see the distance here is a little bit larger than the design value because we consider the compensation. And then we have already finished the simulation. So now let me show you the warpage result. So now we can see the original value, including the compensation value, and the deform length here just become exactly meets our design value, right? So we know the shrinkage is still there, but the deform value just meets our design value. And so by using this way, we could help our user to do the compensation design when they have the tooling design. And so we have talked about the measurement of the linear shrinkage and how to deal with the shrinkage compensation by using Moldex3D. If you are interested in this tool or these features, please feel free to contact us or leave us a message. And thanks for your attention. Have a good day.